Okay, I think maybe we'll get started. Looks like we've got a good number here. All right, good afternoon. I'm Marjorie Kaplan, and I'm joined by my colleague Lucas Markson, and we co-direct the New Jersey Climate Change Resource Center here at Rutgers, which is created by statute. We're a center of applied climate research, practice, and education to help New Jersey mitigate, plan, and adapt to climate change. For those of you not familiar, you can find out more about our center, watch past webinars, explore our climate mapping tools for New Jersey, and read our reports at the links I'm about to put in the chat. So here you go. We welcome your participation in today's webinar, and you can also join us this coming Monday, June 15th at noon for another Climate Academy on climate smart invasive fish management for New Jersey, where Dr. Julie Lockwood and Dr. Mario Hernandez will discuss what freshwater aquatic invasive species are, why we should care about them, how climate change is affecting their occurrence, distribution, and impacts, and what feasible management actions are New Jersey can take to address these impacts under a changing climate. And I'm going to put all that information, a link to all that information as well in the chat. Today's webinar is going to last until 1 o'clock. We are recording today's webinar, and it will be available on our Resource Center website. And I'll put the link to the recordings in the chat here as well. And other than today's presenter and the Rutgers team here, you are all muted. So to communicate with us, please type your questions into the chat box. We have allocated time at the end to get to your questions, and we'll be monitoring the chat box behind the scenes and gathering your questions so you can put them into the chat throughout the webinar. I also want to give a huge thank you to our colleague, Dr. Oliver Stringham, for his help with today's webinar. Today, we have 4 fantastic Rutgers experts to discuss the newest in our annual State of the Climate New Jersey series. We are joined by, in order of their appearance, Dr. David Robinson, the New Jersey State climatologist and distinguished professor in the Department of Geography, Dr. James Shope, extension specialist with the Department of Environmental Sciences, Megan Sweeney, who just completed her graduate work in atmospheric sciences here at Rutgers, and Dr. Anthony Broccoli, distinguished professor in the Department of Environmental Sciences. And so James is sharing his screen, and he's going to be advancing the slides. But as I turn it over to Professor Dave Robinson to kick off today's presentation, I want to congratulate you, Dave, on your amazing career and wish you the best in your forthcoming retirement at the end of this month. We are all so grateful to you, Dave, for your service, not only to our state, where you've served as the New Jersey State climatologist since 1991, but also recognize your contributions to the scientific community and your incredible body of scholarship from New Jersey's Weather Network to leading the Rutgers Global Snow Lab and so much more. Thank you. And with that, I'm going to ask you, Dave, to take it away.
Well, thank you so much, Marjorie, for the very kind introduction. It is bittersweet, but it is time to pass the torch. So let's, before I get out of here, talk about the last year plus of our weather and climate around New Jersey. So good afternoon, everyone. There's our intro slide. Moving on, a little retrospective. Every year we've come up with a top 10, and you can go on the state climate website, njclimate.org. By the way, stay tuned. There's going to be a whole new version of our website coming up, melding our Weather Network site and our state climate site, hopefully before July 1st when I'm out of here. But looking at the past year, really the top 5 big ones were our continuing drought. And it does continue. It continued from 2024 into 25 and to present. We'll cover that in a few slides. We had deadly storms in July. It was a bad month. 2 lightning strike deaths around the state, a flash flood that killed multiple people in the Plainfield area, and also straight line winds in the same area of Plainfield just a couple of weeks before that July 14th event. We had a wildfire, almost one of the top 10 wildfires by acreage in New Jersey history. But I think even more notable in that April event was how close it came to a major, major issue as the fire hopped the Garden State Parkway and threatened neighborhoods in the Forked River and other areas. Then we had some coastal flooding from a stalled nor'easter in early October that did quite a job with beach erosion and coastal flooding. Um, we had a late July heat wave. You're going to hear a lot more about that and better from me, from Megan in just a little while. And going on to the next slide, just quickly, there was another coastal flooding event associated with Hurricane Erin in late August of last year. It's a perennial addition to this list. It was a warm year. However, we got a little reprieve. It was the coolest warm year since 2014. But looking back at 132 years of record, it still came in as the 21st warmest year on record. And then wind, I get a lot of questions about that. Are we getting windier? There's no definitive proof. Our weather network hasn't been around long enough to give you a lot of sites around the state, but there were a lot of notable wind events. And then we had a heavy snow event in South Jersey, a little off kilter where we had different snow events. And that continued into 2026, where we had a widespread snow event, which did a lot of damage to trees down in the pinelands. And then a late end to the growing season. It took to the last week of November for the first freeze to occur at some of our coastal stations. Yet 2 months earlier, we had our first freeze in a deep valley station in Sussex County. Moving on. Let's look at the persistent drought. There you can see the distribution of precipitation last year. Suffice it to say, it was all below normal, but in particular in the Southwest and portions of the Northwest. Next slide. These are not the slides that I have on the deck that I have contributed online. These were preliminary slides. I don't know what's up. Maybe I should try sharing because these don't tell the whole story. Well, we're not going to have time. I'm just going to have to tell the story and maybe we can get the deck when it's posted correct. But 22 of the last 25 months in New Jersey, back to May of 2024, have had below normal precipitation. On this graph, you can just see 12 months, the red bars going with below normal months of precip, the green above. We have had 75% of normal precipitation over the last 24 months. That's missing 6 out of the 24 months of precipitation. Obviously, it's been more distributed, like more equitably distributed, but still, we're not getting rain often enough. And when it rains, the vents are underperforming. And with that, we are in the midst, and you're not going to see the next slide, was going to show you today's release of the National Drought Monitor. And with that, the far South Jersey is now considered to be an extreme drought, D3 on the National Drought Monitor, something you only see about once a generation. Most of the rest of the state up through central Jersey and part of the Northeast is now in D2 drought, which is considered something that only occurs every 10 to 20 years. And then the rest of the northern part of the state in D1. We are in a drought watch, a drought warning, according to the New Jersey Department of Environmental Protection, that have been in some time. So we need rain. 2025 exemplified that, and it's continuing here into 2026. So let's see what the next slide has. Yeah, this is temperatures. I have a slide with the temperatures updated through the last 25 months. Interesting that the last 2 winters have had below normal temperatures. Those are the blue departures from normal, and last August. The previous winter had been somewhat below normal, but the summer months and the warm season months have been above normal. The last 2 springs have tied for the fifth warmest in 132 years. And you can see some monthly records there as well, including this past April, which was the sixth, as it says, the sixth warmest April. But this spring, March, April, May, came in as fifth, tying with last March, April, May. So the next slide. This is something that's been done in cooperation with NJDEP for years now. Very quickly, the top figure shows temperature, the bottom figure precip. 1895 on the left, 2025 to the right, and every month of the year from top to bottom, January through December, January through December. The top figure, the red boxes are months that have fallen in the top five for that particular month for warmth during that 132-year period. The blue boxes in the top five for cold. And you'll notice very quickly that the last blue box was December of 1989. Since then, it has only been top five warm months. And as a matter of fact, 49 of the potential 60 top warmest months have been since 1990, pitching a shutout here, which is, in my years as a state climatologist, this will go down in my mindset as the most remarkable graph I've witnessed. The bottom figure shows a more equitable distribution of wet and dry months, but notice the dark blue and the dark red is more concentrated in recent decades. And I should have mentioned the darker the box, the closer to number one or number two in the rankings. So we've had a lot of extremes in recent decades. The driest month, the wettest month. Early in the 20th century, you don't see as many dark colored boxes. Moving on, the Jones Road fire. And there you can see a satellite image of smoke coming across Jersey out of that fire on the left. A radar image, normally picking up precipitation. It didn't have much precipitation to pick up last year, so it picked up the smoke from the wildfires. And you can see how that blew off the coast. And then the heroic efforts of firefighters from the local level to the state level in keeping the flames somewhat under control and the cooperation of emergency management officials and the public to evacuate when asked to evacuate led to no serious injuries and very little building damage from what was, as I said earlier, quite a threatening fire. The next slides show you the situation with the flash flooding events. And as we often see in the summer, there's very limited coverage of these heavy precip events. On the left, you can see one over northern Burlington County from August. That green shows you where the heaviest precip was located, whereas very little rain fell elsewhere. The one on the right is the July 14th event. There was a little more widespread precip, but you can see the concentration right up there on Route 22 at the Somerset, Union, and Middlesex County borders in the Plainfields area. Next, we look at what is the most notable event so far in 2026 in terms of an acute event. You know, drought is lingering, of course, but we had, if you remember, a very warm middle of April. Temperatures got into the 90s on two, some places three consecutive days. The blooms were coming out in full force, and then along came a late season freeze on the morning of the 21st of April. And the map on the right shows you essentially everywhere in the state, except in urban and coastal areas, temperatures went below freezing. And they didn't just go a little below freezing. The bottom chart shows you at some of our selected stations the number of hours that temperatures were below freezing, below 28, a very crucial threshold, and below 24, 24 and below, which at that level, mitigative actions, fans and smudge pots and putting water onto vines and trees to insulate them just fail. And as a result, you can see a vine up in a western Warren County vineyard where over 80% of the blossoms of the buds were lost. And that's a common value seen from stem to stern with peaches and apricots and apples and at the vineyards with grapes and so on and so forth. Likely well over $100 million worth of crop damage. So this is a very impactful, and it was a result of extremes. We had thermal whiplash back there in April. And as a result, a big hit on our agricultural industry. And that, the next slide, shows you just some of the flooding events from Erin and from the nor'easter in October. They kind of tell their own story. The next is where I'm going to pass the torch under James. It's been a pleasure working with everyone on this meeting and others around the state, and good luck to all. Thank you.
All right, thank you so much, Dave, and thank you for that review of kind of the extremes that we've dealt with in the past year. So now I want to talk about our climate trends, kind of at a global scale, and then into New Jersey before we get diving into some more specifics with Megan talking about extreme heat. So I want to start with talking about our global climate drivers. Nothing new if you're on this call, but what's contributing to our global warming is the combustion of fossil fuels that puts greenhouse gases into the atmosphere. So we're talking coal, petroleum, natural gas, emitting greenhouse gases like carbon dioxide. We emit about 10 billion tons of carbon per year into the atmosphere. And each year we provide this, each year NOAA provides an update for the amount of carbon dioxide in the atmosphere. We like to show that. And we see that there's this increase in carbon dioxide fraction in the atmosphere, and we're sitting above about 425 parts per million today. So the amount of greenhouse gases is increasing in the atmosphere. And if we want to look at the kind of share of how much each one's responsible for, we can look at this graphic here from the NOAA Greenhouse Gas Index. In this case, I believe it ends in 2024. They update it. There's a delay in when they update it. And you can see that the two largest drivers are carbon dioxide and methane. Carbon dioxide is responsible for about 66% of the warming that we see each year, and then methane's at a smaller, about 16%, and then we have nitrous oxide and then various halocarbons. So we target and we talk about carbon dioxide and methane a lot because they're the biggest fraction responsible for the amount of warming that we observe each year. Now, global temperatures have been increasing. There's variation from year to year, but what we're showing here is the temperature anomaly. So basically how temperatures change relative to an average, in this case, centered on centered on the first half of the last century. And you can see that temperatures were fairly stable at the beginning of the last century. They began rising a little bit, plateaued around the 50s and 60s, but then we see this very strong increase since then. Now, even though we've seen this very strong increase in warming, there are still peaks and valleys year to year. It's not every single year is warmer than the next. You have very strong events like El Nino events here that can drive up global temperatures, but then they can swing down in the opposite direction. So what we're looking at is the trend over time, not necessarily a year over year increase. Now, that increase is not manifest everywhere at the same rate. What we're seeing here is the ERA5, that's a reanalysis product, trend in average temperatures, now degrees Celsius per decade. And the big takeaway from this is the areas that are warming faster are in the more northern parts of the world, and then you have other spot areas where it's warming at a faster or slower rate. And all that to be said is the world's not warming at the same rate everywhere. There's hot spots and let's say, I'm not going to say cold spots, but lower hot spots as we're going along. And when we talk about climate change, we think about what may happen in the future. And to do that, we look at a number of different scenarios of how the world may change based on socioeconomic pressures, technological developments, and projections of how we may continue to use fossil fuels. Now, this is showing how that may change in the future relative to this pre-industrial period of 1850 to 1900. And if we look compared to this pre-industrial period, today we're sitting at about 1 to 1.25 degrees Celsius higher than that period. And into the future, we have this range of increased warming. The scenarios that we're most currently tracking towards is this gold scenario and this lower red scenario. So we're looking at somewhere in the ballpark of 2.7 to upwards of about 3.5 degrees of warming by 2100. Now, we care about that warming at a global scale because it drives a whole bunch of these extreme events that we see at our regional weather scale, such as more destructive storms, heavier flooding in some areas, greater dry conditions or drought in others, as well as conditions that are primed for wildfires in a lot of our forests. So, we've seen a lot of these hazards even in the last year. And certainly with the drought and the wildfire, we've been experiencing that here in New Jersey. Now, if we want to focus in specifically on New Jersey, we can begin to divvy this into smaller categories. And looking at temperature and heat here in the Garden State, oh, there's a little bit of issue here. But broadly, our temperature trends follow a very similar pattern where they were increasing towards the beginning of the prior century. They decreased a little bit or plateaued around the 60s and 50s, and then we've had a much stronger increase. If we were to take a look at the rate of increase over this entire period, if we were to track it from 1900 to today, the rate of increase is about 0.33 degrees Fahrenheit per decade. Doesn't sound like much, but if we track it from 1970 or so to today, it's about 0.66, so roughly double. The entire point of this is, while global temperatures have been increasing, they've been increasing at a faster rate in more recent years. And taking those projections that we were looking at earlier, but painting it for New Jersey specifically, we expect that compared to roughly today, under a moderate amount of global warming, we expect our temperatures to be somewhere in the ballpark of about 4 to 6 degrees Fahrenheit warmer, and then with a higher degree of warming, around 6 to 8.5, 9 degrees warmer on average. So the short answer is New Jersey is going to get warmer as we move forward. The amount of warming that we experience will depend on those global greenhouse gas emission levels. Now, we care about that in the Garden State for a whole bunch of reasons. First, a huge amount of our land area, compared to a lot of places, is urbanized. So our citizens and our residents there experience a greater amount of extreme heat exposure just because of the urban heat island effect, and that can affect our health. You see higher rates of cardiovascular issues, higher rates of asthma and the like, especially linked to degraded air quality during extreme heat events. Basically, certain types of pollutants like ground level ozone are generated at a higher rate on warm days. We also expect to see an increase of vector-borne diseases associated with certain pests that like the warmer conditions, like certain species of mosquitoes and stuff that carry West Nile virus and the like. And then the heat also affects our infrastructure. From like bridges comparison, they wear and tear more on hot days. But if you start looking at the conversation today around our power grid, which is being stressed as we think about data centers coming online, as well as other pulls on it, those in hot temperature days will result in more air conditioning use, which can further stress that system that we're already starting to see what happens when we begin to overload it. All right, so transitioning from talking about heat, the next thing I always think about is sea level rise. And the rationale for that's maybe a little straightforward. You think about increasing temperatures, you think about melting ice. So global mean sea level has increased over time. This is showing relative to 1900 how much sea level has increased in meters by 2020. And we're seeing that since that time, global sea levels have increased by about 3/4 of a meter. Taking our suite of projections forward, we can kind of map the same things, and we see that we're thinking 3/4 of a meter on average. We're going to ignore this high impact piece for now. We'll come back to that. But we're looking at about 3/4 of a meter of sea level rise by 2100. Now, that's not what we experience here on the ground. Global sea level is the average across the entire ocean, but we experience sea level rise at different rates depending on changes in regional circulation patterns, regional salinity, and also how we on land are sinking over time, whether our land is rising or falling. And here in coastal New Jersey, our land is falling. This graphic here is showing the amount of sea level change, what we call relative sea level change, that incorporates that decrease or that sinking of land or rising of land over time from 1960 to 2020. And you can see that the Mid-Atlantic here is a hot spot. In Atlantic City, our sea levels have risen about 19 inches since 1911. So we've seen a very dramatic increase compared to other places like, say, California or Alaska, where their land's actually rising over time, so they don't experience it at a higher rate. Now, as we think about what's going to happen in the future, one thing I want to plug is that we have updated sea level rise projections for New Jersey, coming from the Science and Technical Advisory Panel report led by Rutgers, but it's a multi-researcher, multi-institutional report that has come out that was released late in 2025 that provides these updated projections. Now, we have this entire kind of key table from the report listed here, but I just want to direct you towards a few key values and key ideas. So the first is we provide this kind of likely range. That's where if you had to put your money down somewhere, you'd probably want to put it in this range for how much sea level may rise by a certain period. Now, we also have this extended likely range that incorporates processes that are at the forefront of scientific knowledge, primarily how we're looking at how glaciers and ice sheets calve into the ocean and how unstable those may be. Incorporating that information is extremely important because it can really swing how much sea level rise we may expect by 2100 or further. So if we were to look at this moderate scenario, our kind of likely range is between 2 and 4 feet by 2100 compared to 2005. And then this kind of upper end is closer to 4.5 feet. With a higher level, it's about 2.5 feet to 4 feet, and then about 5 feet. So sea levels are going to rise. Another interesting thing is by 2040 and 2050, it doesn't really matter what our emissions direction is. We're going to experience about the same amount regardless. So we're looking at in the ballpark of about 1 to 1.5 feet between 2040 and 2050 within New Jersey. So our sea levels are rising, and we have updated projections that help us gauge where we want to plan based on our risk tolerance level, depending on what endeavor you're embarking on. Now, we care about those higher sea levels partially because of the encroaching land, but also because they enhance storm surge. I've shown this graphic in pretty much every single Climate Academy I've done because I love it so much. But if we have an existing structure on land in high tide, not a big deal. You tend to build for that. And if you have a storm like a nor'easter come through, hopefully you're building to specifications built from that kind of storm climatology, such that the storm surge itself, which basically just stacks on top of your high tide, doesn't impact the house. But with sea level rise, you raise that high tide baseline such that your storm surge is now at a higher level, can flood inland further and cause more impacts. And we've seen that with Hurricane Sandy. It's been estimated in a recent report about 13% of the property damage from Hurricane Sandy, to the tune of about $4 billion, was caused by just higher sea levels due to human activity. And moving forward, we expect our coastal flooding events to become more frequent, as you don't need as big of a storm to generate the same level of extreme flooding when your sea levels are higher. Now, transitioning and talking about precipitation. Precipitation in New Jersey is it's been pretty stable in terms of the amount we get over time. The black bars in this graphic here, showing total precipitation by year, are just the decadal averages, and you see they don't change very much. But where you see a lot more change is in how variable our rainfall is. So the green line is just the actual average total amount of rainfall. And you can see that beginning half of the last century, there's swings back and forth, but it's much more stable than it is today. We're seeing very wet years, very dry years, and we're in a very dry period right now, as Dr. Robinson indicated earlier. Moving forward, what we expect to see with kind of moderate emissions is a small increase in rainfall in the New Jersey area, and you could see that much of the U.S., especially up in the Northeast, expect to see much more rainfall by the end of the century. So somewhere between 3 and 13% increase. But where there's maybe a more, I won't say important, but much more dramatic changes with extreme rainfall. So here in New Jersey and in the U.S. and in the Northeast of the U.S., we've seen much more extreme rainfall. So the graphics here are showing the number of days across the Northeast with 2, 3, 4, and 5 inches of precipitation or more. And you can see that each one has increased dramatically with our more extreme events, like say the 4 inches or more a day, increasing at a much higher percentage compared to even smaller extrema. So we're seeing much more frequent extreme rainfall events. And for the DEP, they actually put forth a study a few years back looking at how our extreme rainfall events, in this case, the 24-hour rainfall event, may change by the end of the century. And we're looking somewhere in the ballpark of 2 to 10% greater in the southern parts, central and coastal New Jersey, whereas in parts of northern New Jersey, we're looking at like a 20% increase in the amount of rainfall associated with these. And all that's we say is our extreme rainfall guidance needs to be based on our historical observations, yes, but also needs to be supplemented by projections for future effects as we're in a changing climate. Yeah, that extreme rainfall, fairly straightforward, causes a lot of flooding, erosion damage. It affects our agriculture in the state. So if we're not getting enough rainfall today, too much rainfall is also a problem. Um, and then the bottom left, we see images of Hurricane Ida, well, post-tropical cyclone Ida in this neck of the woods in Manville, causing flooding in the area. And we also have infrastructural issues with our stormwater systems, which can cause outfall of combined sewage and stormwaters into rivers. So there's a lot of issues with this extreme rainfall moving forward. And then I want to just touch a little bit on what we expect with um, extreme tropical cyclones, so things like hurricanes. Um, in recent years, we've been kind of in this above normal category, as indicated by the NOAA Accumulated Cyclone Energy Index. That's a lot to say. Like, basically, is the Atlantic basin or the North Atlantic seeing a bit more energy, whether it's um, more higher category hurricanes or just more compared to prior seasons. And you see that there's a lot of variability, but in the last 20 years or so, we've been seeing a lot more of these peaks. So what we know is that warm waters fuel our hurricanes. As the world warms, so does our ocean waters. So we expect them moving forward to be more energetic, intensify more rapidly. Like this is Hurricane Ida before it made landfall in Louisiana, became more. It rapidly intensified before making landfall, and we expect them all to bring a lot more rainfall. So that picture of that hazard is going to become more intense and somewhat more complicated moving forward. Now, what we don't know is how their tracks are going to change, or we don't really anticipate their frequency changing very much. Um, and then think about other big storms that impact us in terms of like say nor'easters. That's still a very active area of research to see how that may change in the future. So now, given that brief overview, I'm going to turn it over to Megan to discuss the June 2022 through 2026 heat wave in New Jersey. And I'm going to stop sharing. I'm going to let Megan share her screen.
Okay, I'm going to share the slides. Okay, so getting right into the heat wave from June 22nd until June 26th of 2025. So we had a very warm June, and that was in part due to the heat wave event that we did have. It was the top 10 warmest June with an average monthly temperature of 71.9 degrees Fahrenheit, and it was the 7th warmest June on record in the entirety of the United States. So the top 10 in New Jersey and 7th warmest for the entirety of the United States. So how did we kind of get into this heat wave situation? Well, so we had a bunch of we kind of had a heat dome that formed over the eastern United States. And a heat dome is kind of a heat area that is a high pressure system that kind of becomes stable over a certain area. And it kind of establishes a closed area of heat that kind of remains not only in the daytime, but also allows for temperatures to remain overnight. So you don't see a lot of cloud coverage, you get a lot of sun, which creates those super hot temperatures that you kind of imagine during a typical heat wave. So the air beneath this dome is super hot, and in this case, we also had super moist air coming up from the Gulf of Mexico. We had winds kind of bringing in that moist, warm air from the Gulf, and that created this super heat dome that we saw for this event, which you can kind of see in the figure here. So in New Jersey specifically, we had also really high dew points due to that influx of moisture coming in from the Gulf. Those dew points reached the mid 70s to low 80s, and that also created high heat indices, which is when you have that combination of heat and moisture that creates super hot feeling temperatures. It creates also a wet heat condition, which kind of which kind of allows for the body to cool itself from sweating. That's when it's reduced. So we had a lot of really hot feeling temperatures across the state. Heat indices across the state were around 105 degrees Fahrenheit, with even some reaching 110 degrees Fahrenheit during the absolute peak of the event, which was around the 23rd to 25th of June. And like I had mentioned, nighttime temperatures remained super high during the event, especially in urban regions such as Newark and Camden. They struggled to kind of cool down at night due to the urban heat island effect, which I'll kind of get into in a few moments. So, taking a look at some of the statewide temperatures that were recorded, a lot of locations either got close to or tied some records. I mean, we saw the highest was Camden at 104.2 degrees Fahrenheit on June 24th. A lot of these did occur on the 24th and 25th of June, but we saw them all over the states, not just in inland locations. Newark, we saw 103, but even along the shore in Atlantic City, Tom's River seeing 103 and 102. New Brunswick looking at 100, and Cape May also hitting 100 degrees. We had about 34 stations that had temperatures between 100 and 102 degrees Fahrenheit throughout the entirety, through a couple days of the event, most of them happening on the 24th of June when we saw the peak of those temperatures. We also had some localized extremes. So taking a look at three different areas, we had Camden, Pennsauken, Cherry Hill, West Stefford. We saw that across even urban and non-urban areas that we did see very high peaks. However, what you can kind of see, especially in the later hours of the 24th of June and the 25th, that those overnight temperatures really did differ from the urban and non-urban areas, the more rural and suburban areas. As you can see, Camden remained very hot overnight, still staying around, this is in Celsius, around 30 degrees Celsius in the overnight hours on the 24th, whereas places like Cherry Hill and West Defford got below that 25 degrees Celsius mark, seeing those cooler overnight temperatures in comparison to our urban areas, which really trapped the heat outside of in that heat dome. So what were some of the public health impacts that we saw from this event? Well, heat causes illnesses, as Dr. Show previously mentioned. You can see cardiovascular and respiratory illnesses, heat exhaustion, dehydration, and that comes from having limiting cooling accesses, which primarily affects vulnerable populations, which primarily are in urban areas. Specifically, in this heat wave, we did actually have a mass casualty incident in Patterson, which is in Passaic County. It was during an outdoor graduation ceremony where 150 individuals experienced heat-related illnesses, and medical systems were so overwhelmed it became a state of emergency. And that was one of those kind of tipping points of like, wow, heat is not just something that seems to be a problem, but it also has very much public health impacts across the entirety of the state. Oops, apologies. So we also saw many infrastructure effects during this event. We saw that roadways will buckle under extreme heat. We didn't have any specific examples during this event, in New Jersey, but I know across the entirety of the United States, there were definitely some areas where roadways were buckling due to the extreme heat. Rail systems can also fail due to extreme heat. As trains go too fast down the tracks, it can kind of warp the tracks to be misshapen. So rail systems have to either slow down or cancel trains or limited their service, especially if the electricity grid is overwhelmed. A lot of those trains do run on electrical systems, so they might not be able to operate at full capacity. Speaking of the electrical grid saw a severe overwhelming amount of usage, especially during heat events, due to people using air conditioning systems and a lot of fans and a lot of electricity. So as you can see in the figure, during the June 2025 heat wave, Pennsylvania, New Jersey, Maryland energy companies saw an increase in electricity demand. And that is not necessarily great because a lot of our infrastructure cannot handle the amount of demand that we are looking for. So a continuation of events such as this heat wave would put a large strain on the electrical grid. So, taking a look at what's to come for the future. Well, we are seeing that the United States the amount of heat wave days has exponentially increased since 1990. We are looking at approximately 20 more days per summer to see extreme continued warming. And with a projected warming of 2 degrees Celsius, we are going to see more hot days, even warmer nights, and very fewer colder days. So, as a result, early season heat waves, such as this June 2025 heat wave, are becoming increasingly more common, which poses those challenges for public health, infrastructure, and energy demand. So one thing that New Jersey already does have is we do have a extreme heat resilience action plan, which does outline the framework for addressing these heat related challenges. But as we can see with the heat wave of June 2025, there are a lot of growing risks for extreme heat in New Jersey, so we must take action very soon. The plan kind of emphasizes the expanding the number of cooling centers in high-risk communities and improving access to real-time heat alerts. And it encourages changing urban planning to maybe increase green spaces and helping those most affected by the urban heat island effect. But continued investment in a lot of these strategies will be critical to helping with future impacts that we will be seeing very soon. And I'm going to turn it over to Dr. Broccoli, who is going to talk about the indicators of climate change in New Jersey.
Thank you very much, Megan. It'll be my pleasure to do that. I'm just going to work on sharing my screen, and I will be with you very soon, or my slides will be with you very soon. So here we go. We're going to talk about diverse indicators of climate change in and around New Jersey. And I want to start out by saying that a lot of the results of that I'm going to be showing you today are in this paper that came out earlier this year in the Journal of Applied Meteorology and Climatology. And a couple of the authors of the paper are here on the webinar. Some of the others are students who worked with us on this project over a period of time. So thanks very much to them. Why are we looking at climate indicators? Well, these local indicators, we think, can better contextualize the local impacts of climate change. We often talk about how average temperature will change, but that's not necessarily something that's easy for an individual to perceive. So we're hoping that these indicators can communicate changes in climate in a way that relate better to what we as people can perceive. And so our team analyzed changes in a variety of indicators. The colors here refer to the map showing the locations where we studied that particular variable. So we looked at extreme heat and extreme cold at about 8 stations in New Jersey. We looked at sea surface temperatures at 2 offshore buoy locations, one near the mouth of Delaware Bay and the other about midway between the New Jersey coast and the Long Island coast. For looking at lake ice, we didn't have any stations with data in New Jersey, but we looked at a couple of lakes in the southern part of upstate New York, and also just outside New Jersey in Port Jervis and further east in Bridgehampton, Long Island. We looked at some indicators of the phenological onset of spring, and so I'll talk about each of these in turn. So here's a table showing data on changes in extreme temperature days. The units here are days per decade. And moving from left to right, we've looked at the changes in the frequency of hot days, defined as days with temperature at or above 90 degrees Fahrenheit. Warm nights, nights where the temperature doesn't drop below 70 degrees Fahrenheit. And then also cold days, days where the maximum temperature is at or below freezing. And what we've seen to varying degrees at the different locations are increases in hot days and warm nights, somewhere in the neighborhood of 2.5 days per decade. And then a decrease in these cold days at roughly 2 days per decade. And I'll show you some graphs coming up a little bit later on that capture other aspects of changes in temperature. We also looked at trends in winter severity, using a winter severity index that was based on four quantities: the total seasonal snowfall, the average winter temperature, the number of really cold days, days where the temperature is below 0 Fahrenheit, and the number of days with snowfall. And these data were all normalized to a scale ranging from 0, if that quantity was at its least severe, to 100 at its most severe. The normalization was done separately for each location to indicate variations relative to the typical climate of that location. That means you shouldn't really compare the locations. What we really want to show are how the trends in winter severity compare across the locations. So here we see the data from a number of stations around New Jersey, and we find decreases in winter severity at all of these locations. The red line shows a trend line for all the available years at that station. And then the cyan line show trends from 1967 to 2022. If we want to kind of compare these stations over the same period, all of them show a decrease in winter severity. Now, looking at sea surface temperatures, again, two locations: the Delaware Bay buoy, southeast of the mouth of Delaware Bay, and the Long Island buoy east of about Belmar and south of about central Long Island. And at both of these locations, we see similar increasing trends in temperature, a little bit larger, maybe for the Delaware Bay buoy for winter temperatures, but a little bit larger for the Long Island buoy in terms of summer temperatures, winter temperatures shown at the top, summer temperatures shown at the bottom. There are obviously large variations from year to year, but again, a clear upward trend in both of these locations. Now, something that maybe is a little bit easier to relate to in terms of how severe a winter is, at least as far as temperature, is whether or not lakes stay frozen and how long they stay frozen. So here we looked at two lakes, Lake Mohawk up in, I believe that's Ulster County, and Mohansic Lake a little bit farther south in upstate New York. And at both of these stations, including Mohawk, where there's a very long record of almost 100 years, we see that the duration of lake ice cover has decreased. At Lake Mohawk, it's decreased from about 120 days during the 1930s to more like 90 days more recently. Mohansic Lake, we don't have as long a record, and it doesn't carry as far forward as the Lake Mohawk record does, but we see a decrease there from about maybe 85 to more like 75 over a period of 30 years or so. And then finally, I want to show you some interesting data here about the phenological onset of spring. And this is a result of a very forward-looking project that was begun in the late 1960s. And the way this project worked is that the volunteers who participated in this project were all given the same cultivar of lilac, a lilac cultivar known as red Rothamogensis. They planted these lilacs, and then each year they recorded the timing of the first leaf, and there's a little picture showing what the first leaf looks like, and the timing of the first bloom, and we have a picture showing that first bloom as well. We looked at the two locations, Bridgehampton on eastern Long Island, Port Jervis right up near the northernmost point in New Jersey. And at both of these locations, the first leaf and the first bloom have become earlier, and by several days per decade at both of these locations, an indication that plants are responding to the changes in temperature, as well as other aspects like lake ice and extreme heat days. So to summarize, hot days and warm nights have increased by about 2.6 days per decade looking around the state. Cold days, where the temperature doesn't get above freezing, have decreased by about 2 days per decade. Winters have become less severe throughout the state, and that's using a measure of severity that takes into account total snowfall, the number of days where snow falls, average temperature, and extremely cold temperatures. Nearby ocean temperatures have warmed by about 1 to 1.5 degrees Fahrenheit, and it should say per decade, in winter, and 0.7 to 1.2 degrees per decade in summer. The duration of ice cover has decreased by a little under 3 to a little over 4 days per decade. And first leaf and first bloom of an indicator lilac species have become earlier by 2.9 to 3.7 days per decade. So with that, I'll end my part of this webinar. But before I do, I want to also congratulate my colleague, Dave Robinson, on his upcoming retirement. And even though we may not be doing things professionally in the same way we have, I know we'll still have many opportunities to talk about the fate of our favorite sports teams. So with that, I'm going to stop sharing, and I'm going to turn things over to Marjorie Kaplan.
Thank you, Tony, Megan, James, and Dave for your superb presentations. And yes, I'm glad we'll all be still able to talk to Dave about your favorite sports teams. So I'm going to turn it over to my colleague, Lucas Markson, who's been curating all of your questions behind the scenes.
Thanks, Marjorie. And I apologize, we do have a short time for questions, so I may not get to all the questions that were asked. Always feel free to email us to follow up if you have questions that weren't addressed during the webinar. The first question is aimed towards you, Dave. This comes from Jenny Ludmer. She says that she feels like she's heard about a lot of late freezes for a while. Can you add some context as to how this 2026 event fits within the history of these events?
Yeah, we don't have a good long-term record of that we've looked at closely, but we still can get late freezes, and that's the concern. We're warming in the spring, as been pointed out multiple times here, but that still doesn't mean that it's winter up to our north, well into the spring season here in the mid-latitudes. And you just need to open the door to some late season cold air that comes into the region. And even if it may not be quite as cold as it was cold in the past, given that it's intruding on an area that's warmed greatly, and spring is advanced earlier, you're asking for trouble. I often say, careful what you wish for with warmer springs, getting out and getting your gardens going and things like that, because winter still lurks to the north. And we've seen examples of that on multiple occasions, not just in New Jersey, but in Eastern North America in the last decade or two.
Great. Thank you, Dave. The next question is for James. This comes from Bill Shadell. He asks, is there a way to extrapolate trends in warming prior to the 1900s and show that?
There certainly is. There's certainly recreations of historical temperatures. I mean, we didn't start tracking temperatures or start having thermometers at the end of the 1800s. There's older data sets. They're just typically a little bit more scattered. So we don't use them for like global analyses and as much, just because it's hard to piece that together at a global scale. But there are historical data that we can pull together. Dave may know better of historical records prior to 1895 in New Jersey. And certainly you can go even further back using various climate proxies. There's a very well-established relationship between carbon dioxide that we can measure in, like, say, ice cores and global temperatures. There's a bit more error or potential uncertainty associated with that, but you can start rebuilding those further back. We typically just put everything relative to this kind of end of the 1800s, pre-industrial period, to just kind of give us a good benchmark.
Great. Thank you, James.
And it looks like Dave came off of mute, so maybe he had some ideas as well.
No, James, you're absolutely right. There was universal measurements of temperature beginning in the late 19th century, but there's scattered ones. There's New Brunswick and Newark records back to the middle of the 19th century. The problem there is they didn't have maximum minimum thermometers. We aren't certain of what the exposure of the instruments were, the metadata behind it. And there are records back into the 18th century at Yale University in New Haven, for instance. So very scattered, as you mentioned. I would look back to the proxy records you mentioned. Maybe, I don't know, in this area, vineyard records like we see over in Europe. But we have to look back to proxy records sometimes to fill in that earlier period of time.
Great. Thank you both. Tony, next question is aimed to you. This comes from Edward Neblock. Humidity seems to be trending toward extremes as well. Is that something that we included in the report?
So I think when Megan was presenting her summary of the heat wave, there was information there about the heat index, which takes into account the effects of both temperature and humidity. And so we do think about how humidity is increasing as well as temperature. And this is to be expected because the air at a higher temperature can hold more moisture. When the oceans surrounding our area get warmer, that is often the source of humidity during heat waves. And so we do expect to see higher dew point temperatures, which is a measure of the amount of moisture in the air, in addition to greater actual air temperatures. And that combination of higher actual temperature and higher dew point temperature means that the heat effects, how it affects people, are going to become even more severe than you would expect just by looking at the change in temperature alone.
Great. Thank you, Tony. So this next question is kind of for the entire group. We've had a bunch of questions come in about the polar vortex. So I'm going to kind of try to combine them together as best I can. Can you explain the term polar vortex and how does it relate to climate change? Does it mean winters are more severe or colder before they become even warmer? And do you expect the continuation of the polar vortex process caused by weakening of the jet stream?
Okay, so I'll jump in here and take this one. The polar vortex is one of those terms that kind of has taken on a life of its own in a way that is probably not how meteorologists would use the term. When meteorologists talk about the polar vortex, they're talking about a pool of cold air in the upper atmosphere that tends to be located over the polar regions, both in the northern hemisphere and in the southern hemisphere. Sometimes you'll hear someone say that the polar vortex has moved over the eastern part of the United States. And literally speaking, that's not going to be the case. But there is a relationship between how circular or non-circular the polar vortex is and the ability of colder air to extend down into lower latitudes. Now, it's still very much an open question whether or not climate change is making the polar vortex more wavy. There's some evidence that that's true in the summer months and that can lead to more persistent heat waves. But the evidence is not that clear for winter.
So
Great.
thanks, Tony. Lucas, I'm sorry, but we have time for one more quick question. And while you're going to find that final question, I'm going to put in the chat a link to a short evaluation of today's program. And we'd appreciate folks filling this out if you can. And also some links, I'll repost some links we shared earlier that you may have missed, including Monday's webinar, if you'd like to join us. So Lucas, final question.
All right, last one for you, James. Can you share your thoughts about the impact of the developing El Nino on New Jersey?
I'm actually going to kick that to Tony and Dave because they have the historical context for it a bit more.
Yeah, well, at this point, an El Nino has not been declared. This atmosphere ocean anomaly in the tropical Pacific that has global ramifications. However, it's anticipated. Models suggest that it could be a rather severe El Nino event with connections globally. For this region, it's not a strong take to the bank situation here. We tend to have more coastal storms during an El Nino winter, which may be hope if we're still in drought come next winter. However, tropical season, as many people have heard, in the Atlantic basin tends to be muted by higher pressures in the tropics and more shearing winds that don't allow these storms to percolate up and develop strength. It only takes one, that's an immediate reminder. But when you have fewer storms expected, that limits or minimizes your chances of that moisture getting up or a storm getting up this way. So that's not good news if we're looking to get some moisture out of this. And let me stop here and defer to Tony if he has anything else to add.
No, I don't really have much to add. I think that's a good description. There's probably some tendency of in El Nino years for not having quite as much Arctic air reach the United States. But it's, as Dave said, it's not strong enough that we're going to go out on a limb and try to say what we would expect to happen this winter in terms of temperature.
Great. Thank you both.
Yes, so thank you both to all of you, to Tony, to Dave Robinson, to James Shope and Megan Sweeney. And Dave, again, we all just extend all of our gratitude to you. And that concludes today's webinar.